Okay, this is your homework help for 4.3 and 4.4. It's all about factoring. And I know you guys have had some experience with factoring, but we're going to try to master it this year. So that moving forward, you never have to worry about relearning the process. When I talk about factoring, typically what we mean is to divide it into parts, into things that divide evenly into something. So if I think about 18 and I want to factor it, oh, I could use 2 and 9, or I could use 1 and 18, or I could use 3 and 6. I can break things into factors or multipliers that produce the result. Well, when you have an expression like this, it isn't quite as crystal clear, but here's what we do know. We want to essentially unfoil this. So if we think about the 4 steps of FOIL, you've got the first, outer, inner, and last. Let's talk about what would I have to put here and here so that when I do the first piece, I get b squared. Well, b times b is b squared. So that helps me out. And then I want to know what are the multipliers of negative 40. And so we're going to list them out. We've got 1 and 40. I'll worry about the negative here in a minute. I've got 2 and 20, 4 and 10, 5 and 8. Notice that the sign's negative. That means one of these columns is going to be negative. The way I decide is I look at this guy. The bigger of the numbers needs to be this sign. So the bigger ones are all going to be positive. So let's put negatives in here. So these are all multipliers that give me negative 40 now. Well, which one, when I combine them, and I put a little plus sign in the middle, gives me 3? The answer is negative 8 and 5. So I'm going to put minus 5 plus 8. This is the same equation but factored. And the way I would check is to FOIL. B times b is b squared. B times 8 is 8b, and negative 5 times b is negative 5b. Well, there's my 3b, and then negative 5 times 8 is negative 40. So I would get the same thing I started with. So your answer is here in blue, this b minus 5, b plus 8. Important ideas, depending on the sign combinations, we're going to have different things. Whenever this is negative, the signs have to be different. If this was a plus sign, and we'll hopefully get a couple looks at these, then the signs have to match because the multipliers would have to have the same sign. So we're going to keep going. Number 9, pretty straightforward. Number 15 and 17 are a very special set of factoring. Notice there's no middle term, but also notice that it's a difference. So the signs are going to be different. So you've got a plus and you've got a minus. We said that if that last sign is negative, we're going to have plus and minus. I know this will be x and x, but what times itself gives me 36? Well, I could use 1 and 36, 3 and 12, 2 and 18, 4 and 9, or I could use 6 and 6. Well, whenever the middle term's missing and I'm doing a difference, this is called a difference of squares. Now notice that we have to be talking about a perfect square here for what we're talking about today, but let's take the square root of 36 and use 6 and negative 6. I'm claiming this is my answer, but let's check it out. X times x, well that's x squared, that's easy. X times negative 6 is negative 6x. 6 times x is 6x. And what happens when I add those? They cancel. And then 6 times negative 6 is the negative 36. So this is actually kind of cool. If I want that middle term to disappear, I need to use subtraction, and I have to use perfect squares, but that'll work. Over here, notice I've got that middle term back. It's here, but x is squared, and 144, that seems like a special number. Let's see if it has a square root. If you take the square root of 144, you learn that 144 is divisible by 12 and 12. That actually might come in really handy. So let's check it out. Let's try x and x. Now notice this is positive, which means these two have to have the same sign. So I'm going to put 12 and 12 in. We could try plus, we could try minus. But here's what I notice. that I'm supposed to add them to get a negative. So I'm going to put a minus and a minus. Let's check this out. If I multiply, I get x squared and minus 12x. I also get another minus 12x, and negative 12 times negative 12 is positive 144. This right here is negative 24x. So my answer is this, but see how I wrote the same thing twice? A simpler way to write this would just be x minus 12 quantity squared, and I'd be done. All right, if we keep moving, number 33, we're going to just keep cruising. It says to find the values of z, or solve for z. Well, whenever I have a square and I want to solve, I need it to equal 0. So first thing I'm going to do is move the 54 back over to this side. I know normally we've been getting everything away from the variable. Here we need everything on the same side. So we're going to have z squared minus 3z minus 54 equals 0. Now we're going to try to factor this left-hand side. We'll have z and z. That's obvious from the z squared. Notice that this is a negative number. The last number is negative. I have to have a plus and a minus. Now I'm looking at 54. I'm looking for factors of 54 that when I add them are going to give me negative 3. So let's see. I'm thinking 9 and 6. But one of them's got to be negative. I need a negative 3. And again, it's negative 54. So which one's negative? Looks like the 9 needs to be negative so that when I add them, I get negative 3. So I'll make the 9 negative here and the 6 positive here. Well, the question we really need to know is, what does that tell me about z? Well, let's imagine that this was equal to 0. If this equaled 0, would we care what was over here? Think about it. Whatever's here plus 0 or times 0 is 0. And the same thing over here. If this parenthesis equaled 0, I wouldn't have to worry about this one. So the way we do this is we set them up on their own equal to 0. And we solve for z. We get z equals negative 6 and 9. That's great, but is there an easier way to get from this line to my answer? And the answer is yes. If we just take the opposite of what's grouped with our variable, like I've been telling you to over and over again, what's the opposite of plus 6? Minus 6. What's the opposite of plus or minus 9? Plus 9. And so we get our values that way. Let's keep cruising. Here it changes the term. It says, what are the zeros of the function? What they're asking us is, where does this function, where does the right-hand side equal 0? This is a graph, a parabola, remember? And we're asking, where does it cross the x-axis? Well, there's going to be 2 of them, and we can find them by putting it in intercept form, which is equivalent to just factoring. Lots of factoring. So I'm going to start with x and x. Notice the last sign's negative, so that means plus and minus. And then all I have left to do is figure out what are the factors of negative 30 that when I combine them give me 7. So I'm going to try 3 and 10, but I need one of them to be negative. Since I have a positive 7 in the middle, I'm going to make 10 positive and 3 negative. Well, it's 10 minus 3, that's 7. So I'll make a positive 10 and a minus 3. So given this, what are the zeros? Or what makes the equation 0? A negative 10 and 3. Those x values will make this equation 0. What's really cool is I can go back to the original version and plug in negative 10 or 3, and it'll equal 0. I don't have to look at it from this version anymore. All right, we're going to switch to the second section, which is going to make this just a little bit tougher. The reason it's going to be a little bit tougher is because we no longer have a 1 out here, a 1x squared or whatever. So it's going to make the factoring, we're going to have to take a little bit more time. I'm going to use what's called the guess and check method. And there is another version, another type of method that I can use here. Here, the signs are going to become a little bit more useful to me. So I'm going to go through the combinations with you. If you have a plus plus in your equation, that means both of them are pluses. If you have a minus plus, okay, so if this is minus then plus, you'd have a minus minus. Notice that if the second sign's positive, they have to match. Let's say I had a negative negative, then I'd be one of them's plus, one of them's minus. The order shouldn't matter, although the numbers are going to determine that. Then if I had a plus minus, again, I'd end up with plus and minus inside of the parentheses, right? So these are in these parentheses that I'd be creating. So keep that kind of in the back of your mind that there's a pattern here. That if we have a positive as our second term, then the signs have to match. And this will actually tell me which sign it is. If it's plus plus, it's plus plus. If it's minus plus, then it's minus minus. And then if I've got this negative as the second sign, then it's just a mismatch of the two of them. So let's go in here. The problem is that 6 has factors of 1 and 6, 2 and 3. And really, there's no predictable way to say this is always how we factor. You have to guess and check. So let's say that I did 6p and 1p. Notice that 1 only has factors of 1 and 1. So I have to put 1 and 1 there. And then my signs are supposed to be plus and plus. I have to check. This is 1p and this is 6p. You only really need to check the O and the I, the inner and outer. That gives me 7p. That's too big. I can't use this combination. So I'm going to change something. In this case, I'm just going to change the p. Okay? Let me come in here. Let's see if we can change these to fit better. Let's try 2p and 3p. Well, now I have 6p. Or sorry, now I have, I have 2p and 3p. That produces 5p. Okay, so this is a much better version. It's factored correctly. There we go. Let's keep cruising. All right, we're going to get the hang of this. So this looks a lot like one we talked about just a few minutes ago. It's got a difference, and if I look at 25 and I look at 4, those are all squares. So this is what's called a difference of squares. Okay, so starting off, I know my signs are different. That's what the difference tells me. Well, what's the square root of 25? That's 5. What's the square root of 4r squared? It'd be 2r and 2r. Let's just make sure that'd be 10r and negative 10r. That would cancel out. So this would work perfectly for me. And then here again, I see this perfect square, perfect square. I'm getting a little used to seeing these perfect squares work out nicely for me. What's the square root of 16? That'd be 4s and 4s. Notice the signs are the same because it's positive here, and this tells me that they're plus and plus. And then 1 only has factors of 1 and 1. Let's check. This is 4s. That's 4s. 4 and 4 is 8. So I'm going to write my answer as 4s plus 1 quantity squared and call that good. Again, talk to me in class. We'll handle things. The section that 30 is in on 4.4, we have to be really careful. It says we're factoring monomials first. That means look for a common term to come out at the very beginning. Won't always happen, but we're going to try that first. So what do all of these numbers divide by? They all divide by 4. And I don't like leaving a negative to start, so I'm going to pull a negative 4 out. And I'm going to rewrite the whole thing, but reduced by a negative 4. So what's negative 8 divided by negative 4? That would be 2. And the y wasn't touched, so 2y squared. Now I'm going to say what's 28 divided by negative 4? Well, 28 divided by negative 4 is negative 7. And again, I never touched the y. And then negative 60 divided by negative 4 is positive 15. Then I have to figure out whether or not these will factor. Well, there's a lot of ways to do it. Quite frankly, guess and check's one of my favorites. And some of you will find different ways for doing it. But I'm going to try a couple things. I'm going to try 2y and y. That can't really change. And notice that it's positive with a negative, so they're both got to be minuses. 15 only has choices of 1 and 15, 3 and 5. But I kind of have to try all of them. 1 and 15. This is 1, that's 15, that's 30, that's 31. So I can change it to 15 and 1. That's a 1 now. Gives me 15 and 2, that's 17. Too big. If I put a 3 here and a 5 here, that's 3 and 10. That's 13. It's not going to work. So I try 5, I try 3. 5 and 6 is 11. It doesn't go any further than what I did initially. This won't work, so I have to stop here. This is factorable, but that's as far as I can go. Normally, if you start with something like in this parenthesis and you try and you can't get anywhere, you just say it's not factorable. Okay, we just have a couple left. If we go to number 32, again, we're just trying to factor and find the values of x that would work. Notice that 16 is a perfect square and 1 is a perfect square. So that tells me this is a difference of squares. So I'm going to say this is 4x plus 1 minus 1 equal to 0. Asking that question again, what makes each of these equal to 0, like we did in 4.3, becomes complicated when we have this coefficient of x. At least initially, it seems like it. Let's take the 4x plus 1 and solve it for 0. We would minus 1. We have 4x equals negative 1. Then we divide by 4. So x would equal negative 1 over 4. I want to try and do this one without all of this work. Okay, remember we always said we take the opposite of that piece. What's the opposite of negative 1? 1. But then we have this coefficient, so let's divide by that, because that's how I would separate it from x, just like I did here. So opposite of that is 1 divided by 4. And you could try that one out just as well, and it will work. Look over here. What's the opposite of positive 1? Negative 1 divided by 4, negative 1/4. So that's actually going to be a way that we can approach these problems for finding zeros or finding solutions without having to do the extra work at the end. Our last one here, number 44, wants me to find the zeros of the function. So essentially I'm asking the same question I asked before. If this f of x is equal to 0, what x values would do that? First thing you always want to do is factor out monomials. Is there anything common all the way across? Well, they're both divisible by 3x. So I'm going to pull the 3x out and say, well, what's 3 divided by 3? That's 1. What's x squared divided by x? That's x. I have minus. What's 3x divided by 3x? Don't say 0. It's 1. Now I want to know what makes each of these two pieces equal to 0. Well, what could I put in to multiply by 3 that would produce 0? Well, x could equal 0, because 0 times 3 is 0, and it's gone. The 3 really doesn't mean much in this problem. Then over here, what would I put in there? Well, the opposite of what's grouped with the x. So I'm going to say a positive 1. And those are my answers. In the end, this is the kind of stuff we really want to head towards. The factoring is just a process that gets us closer to finding our zeros. Hopefully this helps, and hopefully you can get the answers you need and get the work done that you need to. All right, good luck, and we'll see you in class.